Whilst we're talking about trig functions, let's recap trig equations. So all the different trig identities and relationships that we've seen so far. We have our compound angle formula. So sine, cos, cos, sine. If it's the sine, it's the sine. Cos, cos, sine, sine. If it's not the sine, it's not the sine. And tan plus tan, or 1 minus tan, tan. We started with those. Then from there we created our double angle ones. So we have our sine 2 theta, 2 sine theta, cos theta. The different variations for cos 2 theta, so cos squared minus sine squared gives us 2 cos squared minus 1. And as we saw yesterday, that's useful integrating cos squared. We can rewrite that. We also get 1 minus 2 sine squared. Again, we could rewrite that as sine squared. Again, useful for integration. And tan 2 theta, 2 tan theta on 1 minus tan squared theta. So they're the double angle theorems. Then we have the half angle theorems, which are known as the T results. And if T is equal to the tan of that half angle, then we know tan theta is 2t on 1 minus t squared, which essentially is just a double angle result. The sine theta then becomes 2t on 1 plus t squared, and cos theta becomes 1 minus t squared on 1 plus t squared. Products to sums. 2 sine A cos A, sine of the sum plus sine of the difference. Why is it sum? Well, it's coming from our alpha plus beta formulas. So when you see sine cos, it must have come from the sine of alpha plus beta to get sine cos. One of them's the sum, one of them's the difference. The cos cos then must have come from the cosine one, because that's the one that produces cos cos, sine sine. But again, it's cos the sum, cos the difference. Sine sine then, it's coming from the cos one as well. But this one now, you'll notice, is a bit different because of that. So sine sine is going to the cos, so it's the cos of the difference minus cos of the sum. Or you might prefer to remember it this way, only because it's always then the sum that comes first and the difference that comes second, if you remember it like that. And we just know, well, sine, because it's a bit different, the difference there, then I start with a negative and go plus. So we change it. But also remember, they're on the reference sheet. So if you're unsure, use the reference sheet to your advantage. It's there to look up. These next ones, however, are not on the reference sheet. Okay? But are still useful to remember. So sine plus sine becomes 2 sine half sum cos half diff. Cos plus cos, 2 cos half sum cos half diff. Notice they're basically in the same pattern. They start with 2, the sine one starts with sine, the cos one starts with cos. And they both finish with the cos. So sine half sum cos half diff, cos half sum cos half diff. Cos minus cos, again the negative here makes it a bit different. So because it's a bit different, this ends up being a bit different. Instead of starting with 2, it starts with minus 2. It's cos, because it's a bit different, instead of starting with cos, we'll start with sine. And again, because it's a bit different, we won't finish with cos, we'll finish with sine. So we get minus 2 sine, half sum, sine, half diff. They're the sums to products, and I've asterisks there to Ryan's, but actually they're not in there. Possibly they might get you to prove it, to use it. They might even give you it sometimes in the actual question itself, because it's not on the reference sheet. But just because it's not on there doesn't mean you can't use it. So if you do remember it, you can use it to your advantage and save yourself a bit of time. Solving our trig equations, the idea is we want to get the angle the same in all the trig. So it might mean using double angle results to change thetas into 2 thetas, or 2 thetas into thetas, that sort of thing. But you want to get the angles the same. Then once you've done that, the range of the answer, if you're changing the angle, then you might have to change where you're looking for solutions. And if they say theta's between 0 and 360, but you've made the angle 2 theta, then you need to look for angles between 0 and 720, because you're finding answers for 2 theta. And then once you've found the answers for 2 theta, divide all the answers by 2, and then it'll get back into the range that they want. Then the trig functions themselves you make the same. Are they all sines, or are they coses, or are they tans? But if in doubt, just change everything to sine and cos, because pretty much every trig function we can bring it back. Tan is sine on cos. Sec squared, well, that'd be 1 on cos squared, that sort of thing. So if you doubt, it might be a last resort, but if you can't think of anything else to do, let's change it to sine and cos and see what happens. And finally, make sure you check your answers. Because you're changing the original question, your answers may well be answers to what you've changed it to, but it might not be an answer to the original question. You might have created new solutions. I mean, if you've squared both sides, you commonly create more solutions, because instead of an answer just being, say, negative, now you've got negative and positive, that sort of thing. Start off with a very basic one here. Cos 2 theta equals a half. They're telling me theta goes between 0 and 360. Different ways we could do it. I could say, well, look, I've got the angle as 2 theta. I'm happy with that, but I'm going to look for answers between 0 and 720. I know I'm in the first quadrant and the fourth quadrant because cosine's positive. Draw myself a little diagram. Oh yeah, that's where it is. That reminds me that the acute angle I'm looking for is when cos would be a half, that's 60 degrees. But I'm looking in the first quadrant, which is that acute angle, and in the fourth quadrant it's 360 minus that acute angle. So I get 60 and 360 minus 60, which is 300. But because I'm going around twice, I need to add 360 to both of those. So they're all my answers for 2 theta. Now we divide it by 2. We've got 4 answers, and they do all lie between 0 and 360, which is what they wanted. And they all do work, those ones. Of course, we could choose to use the double angle result and bring it back to just cos of thetas. So cos of 2 theta equals a half. I'll change that to 2 cos squared minus 1 is a half. That gets me cos squared is 3/4. Cos is plus or minus root 3 on 2. So I'm actually in all 4 quadrants now, because it's plus and minus. So I'll get the whole butterfly there in my diagram. The acute angle would be 30 degrees. I get my 4 answers straight away this time. Bang, bang, bang. But obviously the same as the 4 answers I got the other way. I mean, how you choose to solve, it's up to you. I mean, it's just different approaches. Okay, 4 sec squared in 3 tan. Okay. The angles are okay, the range is okay. I've got sec and I've got tan. I'll change my sec squared to be 1 plus tan squared. Now they're all tan. So I've got a quadratic. 4 tan squared minus 3 tan and minus 1 is 0. So it factorizes nicely, which is good. Tan x is minus a quarter. Tan x equals 1. We've now got 2 of our simple little trig equations to solve. We just go solve each of those individually. So the first one there, quadrant 2 and 4. The acute angle, 14 degrees 2. It's not a nice, neat, exact one for us. And okay, we do our calculations. We've got those 2 answers. Over on the right hand side, tan x equals 1. I'm in the first quadrant or the third. That one is one of our exact values, isn't it? So 45 degrees, tan of 45 is 1. And we get another 2. Write your final solution down. It's not for whoever's looking at a solution to pull everything together and go, oh look, you got 2 solutions over here, you got 2 over there. No, write them all down. Here's all the solutions. I like to put them in order. I suppose you don't have to, but I think it looks nice when they're in order. Cos 2 theta and cos squared theta and sine squared theta. So we've got a mixture here. We've got angles that aren't the same. We've got trig values that aren't the same. So I think the first thing I'll do is change the cos 2 theta. I'm going to actually change this one to cos squared minus sine squared. I mean, I could have chosen one of the other ones and played around, but I've gone this way. And the reason I've gone this way is I can now say, well, 3 cos squared is sine squared. I can rewrite that as tan squared, because sine on cos is tan. And that gives me tan is plus or minus root 3. I'm in all 4 quadrants because we're plus and minus. Acute angle 60 degrees. There's my 4 answers. Here's one from an HSC. Quite old, 2000, wow. Cos 2 theta is sine theta. No, simple 1 to 1. Okay, I've got the double angle. Let's get rid of it. Makes sense to turn that one into 1 minus 2 sine squared, because now we've all got sines. We have a quadratic. It did factorize nicely. Sine theta is a half, or sine theta is negative 1. So the first one, I'm in quadrant 1 or quadrant 2, which has an acute angle of 30 or 150. The second one though, sine theta is negative 1. Well, they're boundary values. There's only one time it's equal to negative 1, and that's at 270 degrees. So I have 3 answers for this one: 30, 150, 270. Even older, 1992, goodness me. 2 sine squared is sine 2 theta. I guess I'm going to change that 2 theta. It does give me both sines and coses, however. But that's okay in this case, because if I pull everything to one side, I can factorise. Now, one of the factors is just sine theta, but the other one, sine theta equals cos theta, I can handle by now changing, well, let's do the left-hand side first. So on the left-hand side, a boundary value. Point to remember here, if I'm looking between 0 and 360, and 0 is a solution, don't forget 360 is also a solution, because 0 and 360 is the same point on that diagram, if you think about it. So whenever 0's a solution, 360's got to be a solution as well. Over on the other solution, I can change that to tan theta is 1, quadrant 3, 45 is our exact value for that one, 45, 225, 5 answers for this equation. Sine theta, sine 3 theta equals a half. So here's one where I can change my product into a sum. So it becomes minus cos 4 theta plus cos 2 theta equals 1. Now, I'll use a double angle result on that 4 theta. I get minus 2 cos squared 2 theta. We can make it look like a quadratic. But by the way, don't forget to change where we're looking for answers. My equation's in terms of 2 theta here, so I'm looking in between 0 and 4 pi. The other thing to make note about this, they've said between 0 and 4 pi. So you do not give your answer in degrees. They've specified the answer needs to be in radians. So if the equation says between 0 and 360, you want to put the answer in degrees. If it's between 0 and 2 pi, you put the answer in radians. Okay, either cos 2 theta is 0 or cos 2 theta is a half. That's a boundary value, so I'll get pi on 2, 3 pi on 2, 5 pi on 2, 7 pi on 2, divide by 2. Okay, we've got 4 answers for that bit. Cos 2 theta equals a half. I'm in quadrants 1 or 4. Acute angle is pi on 3. And again, we get 4 possible answers there. Divide those by 2. And this is where it's fun if you want to try and put them in order. Oh, which one's bigger than which? There's the order they go in. But as I say, you don't have to put them in order. You could just list all 8 solutions there. Okay, I think this is the last example. Let's finish up with this one. From the 2021 HSC, it was a very interesting question. So they told us the numbers A, B and C are related by this relationship here, these equations. A is B minus D, C is B plus D, D is some constant number. We have to show that the sine of A plus the sine of C on the cos of A plus the cos of C is the tan of B. Show that. Well, to show that question I can do simply by substitution. So I'll look at the left-hand side and I'll substitute in what they gave me. Sum to product. We've got sum to product. Right? So that's what I've used here, sum to product. And because it's a show that question, and it looks like I've just jumped to this, I've put that explanation down. So this is where I got it from. I haven't just pulled it out of thin air. It's the sum to product. Remember, the top of the fraction, sine plus sine, 2 sine half sum cos half diff. The bottom of the fraction becomes 2 cos half sum cos half diff. Remember, these are the ones that are not on the reference sheet. So if you remembered these, my goodness, that saved a lot of time. If you didn't remember these, and it's not on the reference sheet, then you would have had to expand out sine by sine, cos, sine, then expand out the other one, then expand the bottom ones out, collect everything together. You'll get the same answer, of course, but it takes a bit more time. Now let's have a look at these expressions. Well, top and bottom both have cos negative d, so they'll cancel. I get sine on cos, which is tan. Here comes the equation part. Hence or otherwise solve this magnificent equation. Wow. But at least if you couldn't do part A, they've given you a hint on how to approach it. And look, they've given us this little formula we could use. And this is in that pattern of the formula, so I can use that. Okay, so here's our equation. If I'm going to use this formula, I need to work out what the pieces are. So what's the A, what's the B, and so on. Because remember, my answer, I'm going to change it to tan B. So I need to work out what B is. But if it's in this form, let's go back, then I know that A was B minus D and C was B plus D. That gives me B is A plus C on 2. Oh, it's the average of the 2. Okay. Well, if I add these 2 together and divide by 2, I will get 11 theta on 14. So we've a much easier equation to solve. Mind you, the numbers aren't nice. because 11 theta on 14, hang on, theta was going between 0 and 2 pi, so what on earth are we going in between? Whoa, so 11 theta on 14, we're going between 0 and 11 pi on 7. Tan's positive, first quadrant or third quadrant. Now, that means the acute angle would be pi on 3. So 11 theta on 14 is pi on 3, or 4 pi on 3. 11 pi on 7 is where I'm going to stop. So if I was to add another 2 pi onto these, I would get something that's bigger than 11 pi on 7. So these are the only two possible ones. Divide both sides by 11 on 14 and we get these two answers. Theta is 14 pi on 33 and 56 pi on 33. A good example of, hey, the numbers don't necessarily work out nice. They're pretty ugly answers, but they are what they were. 11a, let's have a bit of a play with some trig equations.